Hello and welcome to StressOff. This is the place where we conduct finite element analysis using several different softwares that are available in the market. Some of them are open source softwares like FreeCAD, Calculix, and Salome Mecca. Some of them are softwares that are to be paid for, like Autodesk Inventor, ANSYS. Some of the softwares like PrePoMax are closed source, but they use Calculix as their finite element analysis engine. All of these softwares will be using to conduct a finite element analysis of a cube. The length of the cube is 1 meter, width of the cube is 1 meter, and the height of the cube is 1 meter. So it's 1 cubic meter cube. The pressure to be applied on the top face is 1 megapascals, and the bottom face will be constrained. There are a few different constraints that we'll be trying out in this software StressOff, so stay tuned. In this video of StressOff, we are going to see PrePoMax, which is a finite element analysis software. Let's go in and create a new model. It'll ask you to select a unit system. We'll go with millimeter ton second. Click on OK. And before we do anything, let's save this file. Next, let's import a file. Now, previously, I have created a step file of the cube that we are going to mesh. PrePoMax can generate meshes. It can conduct finite element analysis using Calculix, and it can do post-processing. The only thing PrePoMax cannot do is pre-processing, which means any geometry that you would like to conduct finite element analysis on has to be done outside PrePoMax. Now that should not be a problem because there are many of the softwares available that will enable you to do that. Before we go any forward, we need to check if the dimension of this block that we imported is exactly what we want or not. So we will click on this first node. It says node ID is 2, and you can see down here what are the coordinates of that: X, Y, and Z. Next, let's just click on this node ID number 5, and it tells us that the coordinate for this node number 5 is 1000, 0, 1000, and the coordinates for node number 2, let me expand this a bit. Coordinates for node number 2 are 0, 0, and 1000. It means that the elevation here for these two nodes are 1000, and this second node is 1000 millimeters from the first node. So in short, these two nodes are 1000 millimeters apart, and this distance is also 1000. Similarly, we can quickly check that this node is also of 1000. As you can see, node number 6 is 1000, 1000, 1000 in X, Y, and Z coordinates. After we are satisfied that the file that we have imported is sufficient in size or is perfect in size, we'll go in and check for meshing. We'll click on meshing parameters, and by default the max element size is 87. Let's change it to 100. We will ensure that the mesh that will be generated is compatible and it's similar to the other softwares or the meshes that were generated in other software. Let's click on OK, and then let's click on create mesh. Here we can see that PrePoMax generated a file, a mesh file, and it went directly in FE model tab. In here, first let's go in and add a material. Let's call it mild steel. Let's add elasticity to it, and let's add 210,000 megapascals of Young's modulus and Poisson's ratio of 0.3. Let's click on OK. For the section, we need to tell PrePoMax that the entire section or the entire block is made up of mild steel. So what we'll do is we'll go in and geometry based selection will just say part, hover over the block, click on it so the entire block is selected. In here it says solid section, material is mild steel and region type is selection. Let's click on OK. That means the entire geometry has been given mild steel as the material. Next, let's go in step and add a static step. Click on OK. Next, for the boundary conditions, let's go in and add, first of all, let's add a displacement condition, and for the bottom face, let's add U3, which is in Z direction, fixed or 0. Let's give it 0 and let's say OK. Next, let's go to loads and create a pressure load on the top face of 1 megapascal. Let's see if we can solve this. FreeCAD was able to solve it, but let's see if PrePoMax can solve it. Right click on analysis and click on run. We will let PrePoMax finish the analysis, and as I said, this is a very simple analysis, so PrePoMax was very fast in finishing the analysis. Let's click on results. Here we can see that PrePoMax allowed you to conduct this finite element analysis. So in other words, PrePoMax is similar to what FreeCAD allowed you to do, but not what Inventor allowed you to do, because in Inventor you could not conduct this analysis. Let's have a look at the displacement. Displacement for all of the elements is 4.992 micrometers, but what we are interested in is displacement in Z direction. So let's click on U3, and here we can see the displacement of the top face is 4.76 micrometers. We will compare this with FreeCAD and also all the other softwares. Next, let's click on Mises stresses, and here you can see 1 megapascal of stress, which is consistent for the entire model. Next, let's go back to FE model. In the boundary condition, let's add a couple of more displacements. For this edge, let's add y as 0, and for this edge and for this edge, let's add x as 0. Let's click on OK. Analysis, right click and say run. Yes, we will overwrite the existing files, and let's see what the results are. Again, PrePoMax was really fast in giving us the answer. Checking the results, we can see that the displacements are nearly same, and the U3 or Z displacement is 4.762 micrometers. Let's check Mises stresses, and they too are consistent. Last, let's go back to FE model, remove all these three displacements, and let's add a boundary condition of fixed on the bottom face. Again, let's click on analysis, run, and we will overwrite the existing file. Again, PrePoMax is really fast. the results were obtained in 5.949 seconds, roughly 6 seconds. And here we can see that the deflection is consistent with what we got in both FreeCAD and also Inventor. Have a look at this. So here you can see the deflection. Because the bottom face is fixed, deflection happens in this particular way. Next, let's check deflection or the displacement in Z direction. Here the maximum displacement is 4.658 micrometers. Let's check von Mises stresses. And von Mises stresses are: the maximum stress is 1.85 megapascals and the minimum stress is 4.959 or 0.4959 megapascal. And the maximum stress is at the corner nodes, as can be seen here, which is again consistent with what we saw with FreeCAD and also Inventor. So that's it for this video. I hope you like it, and I hope that you join me for the next video where we conduct finite element analysis for a different video of StressOff. Thank you.